All right, so we're in 5.5. This is side, 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 and hypotenuse-leg theorem. Hypotenuse-leg theorem obviously doesn't follow the side and angle naming convention that we've gone over so far, but it falls into these categories. Let me clear the chat here. So previously we've done side, angle, side. And what we found is if we have two triangles that have side, angle, side, so two sides and the included angle, congruent to another triangle that's two sides and an included angle, if all three of those pieces match up, then the entire triangle is congruent, those two triangles. And now we have two more ways that we're going to learn. The first one is side, side, side. That is, we will never write out side, side, side again. So the side, side, side congruence theorem. If three sides from one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if I can get that all three sides are the same, that means that the entire triangle is the same. That means the three angles are the same as well. So that is the side, side, side congruence theorem. It requires that three sides are congruent to three sides. Let's go with an example of what this looks like. So there's two ways that we can see this happen. One is with the triangles broken apart from each other. The other way is that the triangles are stuck together. We could have a segment bisector, meaning we cut something perfectly in half. It all depends on the information that we see. But let's start off with something basic here. Okay, so we've got these two triangles, A, B, C, X, Y, Z, and we've got some congruences. Now, when we look at these two triangles, all three sides from one triangle are congruent to all three sides from another triangle. If we were asked, is there enough evidence to prove that these two triangles are congruent, we would say yes. These two triangles are congruent. So these two triangles are congruent. We need to be able to, again, make a congruence statement. Let's start with triangle ABC. It's going to be congruent to this other triangle. We have to get this congruence statement correct. Everything has to match up. So if we look at angle A or point A, on one side it has the the 1 marked side congruence. The other side of it is the 3 marked congruence. That matches up with X from the other one. It has the 1 congruent mark and the 3 congruent mark. So A and X are in the same position. They are congruent to each other. They're in the same spot. They correspond, right? They're corresponding parts. What we can do next is we can do the same thing. We can say, okay, here's B. It has its two sides are the 1 congruence and the 2 congruence. Well, Y has the 1 congruence and the 2 congruence. So that means that B and Y are congruent with each other. The last piece falls into place. C is congruent with Z. They're the only ones left. The other way we could have done this is once we find one of the congruences, we just walk around. So if we started at A, we would walk across that first congruence and run into B. We start off at X, we walk across that first congruence, we run into Y. B and Y are at the same spot in the path. Either way that we want to do it is acceptable. But these two triangles are congruent. Triangle ABC is congruent to triangle XYZ. And there's nothing really fancy about it. That means that all the angles are congruent now. We could add in that. We've got a congruence there. We've got a congruence here. And we've got a congruence here. We could fill in the rest of the information. Okay, let's do one more example of this. Let's not do it quite like that. Let's go with that's pretty I'm going to switch to graph paper so I can get this more accurate. Okay. Okay, so here we have two triangles. I'll drop the paper. And we're going to be given some congruences here. Let's go here and here. We've got some points, A, B, C, D. And then the question would be, do I have enough information to show that these two triangles are congruent? I've got two triangles here. I've got ABD and ACD. Do we have enough information to show that they are congruent? And so I'll ask that to the class. We'll just do a yes/no poll. Are they congruent? Yes or no? Is anyone awake? Yes or no? Can anyone see the poll? If you can see the poll, you should be answering the poll.
Wait, what was the question?
Are the two triangles that I have up here, ABD and ACD, do we have enough information to show that they are congruent? Okay, so we've got an answer through voice saying yes. All right, so let's check it out. Okay, one thing we have here is a shared side, right? I don't have the third congruence showing, but we'll ask the question again here. Are the two triangles congruent? And the answer is going to be yes. And the reason why is there's a shared side. And we have side, side, side. So it is a little bit of a trick, yes. There's a piece of information here that's not given to us explicitly, but there is a shared side here. These two sides, if we separated these two triangles, that distance from A to D on both of the triangles is exactly the same. It's a shared side. So I've got these two triangles. I've got ABD triangle. That looks like an A. Triangle ABD. That's the triangle on the left. So I'm starting at A, going to B, and then going to D. It's going to be congruent to the other triangle. And this other triangle, well, A is going to be congruent with A, and here's why. If I look at A, it's made up of the one congruent side and the three congruent side. One congruent side, three congruent side. That's angle A for that upper triangle. Next up we have B is going to be congruent with C. B is the one side and the two side. C is the one side and the two side. So B and C are in the same spot. And the last one, D, on that left triangle, it's the two side and the three side, the two side and the three side. So ABD is congruent to ACD. And the reason why is there's this shared side. If we split these two triangles apart at that side, it would be the same length. So when we have shared sides, they are the same length, they're congruent. So AD from the left triangle is the same as or congruent to AD from the second triangle or the right triangle. They're the same. Let's do one more of these that you might run into, and it'll kind of change the way it looks. Okay, we've got a rectangle, and we'll split it like that. And we'll do side congruences here. We've got 1, 2. So we've got two separate triangles here. Again, I'll ask you using a poll, yes or no, are the two triangles congruent? Yes or no? Are the two triangles congruent? Is no one awake? It's already 10:30. We should all be awake. Okay, so yes or no? Why is it not showing up in the... That's weird. There's something going on with Zoom then. Okay. Oh, well, my Zoom is not... Here, I'll share the results. It shows that no one is answering, even though you guys are saying you answered yes. So that is weird. So again, the answer would be yes, and the reason why is there's a piece of unwritten information in here. I have... let's make that not such a dark purple. We've got this shared side again. So we've got a shared side. That means that all three sides are congruent. But when we write this one out, we're going to see that it's written out a little bit different. And when we talk about those sides being congruent to each other, it's going to look different. So here we go. Let's start with the triangle up and to the right, or the one on the right, or the upper one. Triangle ABC. So yes, they are. We've got a shared side. We've got side, side, side. Now, we're going to write out this congruence, and we're going to talk about that shared side. We've got triangle ABC up above. The first triangle we get for free. We get to write out however we want. It doesn't matter. The second triangle, though, it has to match. So the first triangle, write it however you want. Pick the triangle that you want, write it however you want, whatever. The second one has to follow the leader, though. All right, the second one. So triangle ABC. Let's start off with point B, because point B is out here by itself. It's going to be easier for us to identify where it goes. Point B has the one congruence and the two congruence. Point D from the other triangle has the one congruence and the two congruence. So D and B are in the same spot. So D is in that second spot. B is in that second spot. They match up with each other. Now, here's where it's going to get a little bit complicated. We're going to talk about A from that upper triangle. So we're going to talk about, let's use a red highlight here. We're going to talk about this angle A and compare it to the other angle A from the triangle on the left, or the lower triangle. So this angle A right here is the one congruence and the three congruence. The 1 and the 3 side. In the other triangle, it's C that is the 1 and the 3 side. So C is the one that lines up with it. So from the second triangle, it matches up with A from the first triangle. The last one has to fall into place. We've got here, this is A from the left side triangle, or the lower triangle, matches up with C from the right side, or the upper triangle. So this is going to be A. And if you notice, we've got A and C, C and A. They're swapped. They aren't in the same spots. So triangle ABC is congruent to triangle CDA. Now, when we talk about this shared side, from this triangle on triangle ABC, this upper triangle, or the triangle on the right, this shared side is AC. We'll call it AC. AC from this triangle is going to be congruent to, well, on the triangle on the left, or this lower triangle, AC, this is going to be CA, right? We've got 1, 2, 3, 1, 2, 3. This is 1 and 3. It's going to be congruent to 1 and 3. Again, they have to be the same positions, right? So AC is congruent to CA. Even though they're the same side, they're not written out the same for these two different triangles. This lower triangle, the triangle on the left, this triangle here, that side, we're going to call it CA. This upper triangle, the triangle on the right, whatever you want to call it, this triangle here, we have to call it AC if we're going to talk about how they're congruent. Again, positions line up with positions. All right, the last thing we're going to talk about today is the hypotenuse-leg theorem. And I don't know if I'm going to be able to show it properly online. It is a special case of something that normally doesn't work, but it works in just this specific instance of a right triangle. So here's the theorem. If the hypotenuse and a leg from one right triangle. So we've got three pieces of information here. We've got a hypotenuse, a leg, and we're dealing with a right triangle. If the hypotenuse and leg from one right triangle are congruent with the hypotenuse and leg from a second right triangle, then the two triangles are congruent. Okay, so if I have two right triangles and the hypotenuse and the leg and a leg are congruent, then we're good to go. But the key is it has to be a right triangle. If it's any other measure than a right triangle, it does not work. And I'll attempt to show it on here. I don't know how well it's going to go, but let's go over why that is. Let's go to graph paper so we can have this accurate. Okay, so we have a triangle here. And then I'm going to make something that's exactly the same right below it. And we'll see how well this goes out. There we go. Okay. So these two are set up exactly the same. And really, we probably don't need the long lower piece, but we'll deal with it. Okay, if we look at hypotenuse leg theorem, we'll make a little hypotenuse leg theorem diagram up here. Right triangle. So a right triangle, the hypotenuses are congruent, and one of the legs, a pair of legs, are congruent. If we set up this triangle like a right triangle, these two triangles like a right triangle, so let's go with purple. We get this hypotenuse leg theorem. We end up with the right triangle. Let's call these the same, and these would be the same. if we make this a right triangle, the two lines here end up being the exact same length when they make that right triangle. So we're forcing it to be a right triangle. These two triangles have to end up being the exact same. But what happens if we don't care about it being a right triangle? What if we just say, okay, let's make it a length of whatever let's go with this right here. Whatever this length is. All I know is I'm going down 6 to the right 1. If I go down 6 and to the left 1, these two red lines are the exact same length. They're the exact same length. So if I have these two sides the same, I could have, and sorry, I'm not worried about those sides, sorry, hold on. If I have this leg and this side the same, now these angles are the same. Yeah. So I have an angle, a side, and a side. I have an angle, a side, and a side. This angle, side, and side are all the same length. They're all congruent. But this combination doesn't work. The only time it works is if we're dealing with a right triangle. That's the only time it works. And this is not the best explanation. It'd be easier if we were on a whiteboard and we could swing a ruler around. But the hypotenuse leg theorem is a special exception to this. When we use a right triangle, it works. If we don't have a right triangle, if we don't have the right angle down here, it doesn't work. So if we did have an instance of angle, side, side, if it's a right triangle, it works. If it's not a right triangle, it does not work. And again, in the classroom, it's a lot easier to show that. But here you can see I've got angle, side, side, angle, side, side. This doesn't work because those sides don't have to go in the same direction, that last side. If that side goes at 90 degrees though, it has to be the same every time. All right, so let's do some examples of this. There's not really a lot to do. We kind of did one earlier when we had the rectangle cut at the diagonal. Let's see if there's an okay example. And we really don't need anything fancy. Let's see if it decides to snap in place. Nope. I don't like that. Okay, so here are two right triangles. Hypotenuse is the same length. One of the legs are the same length. And if we look, we've got angle, side, side, angle, side, side. As long as that angle that's showing is a right angle, then we're good to go. If it's not a right angle, it does not work. So angle, side, side, angle, side, side doesn't work unless it's a right triangle. Okay, so the question being, are the two triangles congruent? And I'm not going to ask a poll because obviously they're not working. So in chat, give me a yes or no. Are the two triangles congruent? And then if they are, how do we know? So I've got lots of yeses. The reason why is HLT. HLT is why these are congruent hypotenuse leg theorem. We've got a hypotenuse and a leg congruence. Hypotenuse implies a right triangle, so they're both right triangles. Yes, they are. Now we need to make the congruence statement, which is sometimes the hardest piece. I've got triangle MNO. In chat, tell me what is the congruence statement. How would we write out the other triangle? So we've got MNO is one of the triangles. How do we write out the other one? I'll give you 30 seconds. What matches up with N? What matches up with N? What matches up with O? All right, I've got a few answers. Just a couple more seconds. Okay. M, or angle M, from this first triangle. Its sides are 1 and 2. Congruence 1 and congruence 2. Congruence 1 and congruence 2, that is R from the second triangle. Now, two ways we can do this. Our triangle goes from M to N, so we're going to go from M to N. That takes us across congruence number 1, going from M to N. M to N goes across congruence number 1. R going across congruence number 1 takes us to Q. That means Q has to match up. N going to the next point, O, takes us across the side with no congruence. Q going across the side with no congruence takes us to P. So it has to be RQP. Now, you can do it again by using the sides. We did 1 and 2 to get M and R to match up. We could go, well, Q is the right angle and N is the right angle. We could use that. Q and N have to be the same because they're both right angles. So Q and N. And again, when we have angle congruences, those are the easiest ones to line up because they fall directly on each other. They have to be the same. When we're dealing with side congruences, like we saw previously, I'm going to scroll up real quick. Like we saw previously, here we've got congruent sides, but it's AC and CA. They're swapped around. So when we have side congruences, they can be in an order that doesn't make sense. But when we're dealing with angles, angles are always congruent to angles. It's hard to misinterpret it. Okay, we're going to go over a couple problems from the homework together, and then we will be good to go. Let me see if I can pull it up here. So what the questions are going to ask you is what congruences are there? And it's going to be a lot of drop-down menus or fill in the blanks. And it's going to ask you if there is enough information to tell whether or not they are congruent. Let's go with... This is going to be question number 6 from the homework. Let's see if this will work here. Let me exit that before we do anything. If this doesn't work, it's fine, and we'll just move on, and the recording will stop. If it does work, it's fine.